Ladies and gentlemen, please welcome to the stage from MWH Global, Rael Romero and Jed Iverson.
Hello, how's everybody doing? Optioneering with SiteSnap technology. My name is Rael Romero, and I am part of the research innovation team at MWH Global. I've had the opportunity of working in this group for roughly 10 years with MWH, and it's part of my role to bring some of the technologies we're going to talk today into the engineering world. Jed?
My name is Jed Iverson. I also have been with MWH for about 11 years. I've been in the AEC industry for 16. I'm also a licensed structural engineer, and I've been able to bring that BIM technology through my career, and now currently I am one of the BIM leaders with our company.
So first we want to set some grounds here is that who really is MWH? And MWH is committed to improving the communities where we live and work by using our technical, engineering, and construction expertise. We address issues of aging infrastructure, scarcity of resources, and lead the industry with technological innovation. So just so you're not wondering who Jed and I really are, that we're just these two guys from Denver, Colorado, is that MWH actually is a global company. There's not just the two of us. And so a couple of the projects that we're working on is, for example, is Miami-Dade. So MWH is providing engineering design services for the comprehensive rehabilitation of 3 wastewater treatment plants down in the Miami-Dade area. It is a $1.6 billion project that involves the upgrade of 3 of their regional treatment plants that services over 2 million people. AMP6 is across the pond over in the UK. We're very instrumental in delivering a $2 to $3 billion capital investment program to upgrade the Thames aging water system. It's pretty old infrastructure over there. And then a little one that hopefully puts us on the map is the Panama Canal. So MWH Global leads the international team in the design of the new set of locks that double the Panama Canal's capacity. The canal's new larger lock system operating together with the water saving basins will allow 60% of the water basins for each lockage, or 8% less water needed for the existing smaller locks. And that's scheduled to open this year. One other little exciting tidbit about it is that the Discovery Channel has done a Modern Marvels TV movie on us, so if you have the opportunity, please check it out. So what we're doing is that we're now trying to take real-time data capture using photogrammetry and scanning, and we're actually trying to make it as accurate as built information. So someone like Jed can take it after we process it and visualize it and integrate it into planning for real engineering. They get a little testy when we give them stuff that's not so accurate, and so that's really kind of some of the workflows and the ways that we're trying to plan this so it really works out in the engineering world. So right now, the project that we're going to highlight today is for the Miami-Dade, and this is their central treatment plant. It's right across the bay, pretty much from South Beach. Great place to go down and work. But what we did is we went in and we set up a site plan. Right? And with setting up a site plan is because you want to work with, you're not just out there with just a pilot, not just going out and flying a drone. You really want to plan out ahead. You got to deal with weather, you've got to deal with all the different types of structures that are there. You have to deal with certain areas that you're not supposed to fly into because actually Miami-Dade's air traffic kind of flows over this area. So it's kind of, there's a lot of things that you got to take in consideration, but then you go out, you plan it, and then when you work with your photographer and your pilot, you want to make sure that you're capturing all the data. So when we're pulling this in and we're getting the data, we want to make sure that the quality assurance is there and the integrity of the model is there. Because we live in Denver, Colorado, it's not like, and our flight crew lives in Texas, so if we just all of a sudden don't have the data, we run into some real issues. Now here are the issues. With the reconstruction processing that we put this through, is when we ran it through the first time in one of the compositing type of photogrammetry softwares that we use, we didn't have all the data we needed. So we actually had to go back out and shoot it. And that's why these layers of dots are all cameras, or all photographs But then there's layers upon layers, because then we realize that on a treatment plant, yes, we have boxes and regular structured buildings, but we have spherics, and we have cylinders, and we have underground kind of like basin things that we needed to capture, which we didn't get those, and we didn't communicate that with our actual drone capturing company. Within the reconstruction process, it can be very labor intensive, especially if your data isn't clean. So we've learned this the hard way, and it's been a long process of re-tagging, readjusting images, and then going in and actually building and adjusting the meshes. Because like I said, passing things off to someone like Jed, who's a structural engineer, they get a little testy when things aren't as accurate as they should be. So now you can see is we went in, we processed all the images. And this is a nice representation, a 3D existing representation of the Miami treatment plant. I know it's a treatment plant, but we all love water, so it's good. So within this, now I have this existing thing that not only can I communicate with the client, I can use this for not only marketing, but social outreach, but now I actually have an edible mesh. When I take this edible mesh, I can pass this off to a civil 3D engineer, and I can also pass it off to a structural engineer like Jed.
So this is where the fun for me begins. This is where the design process really starts. So with the photogrammetry, we don't quite get the accuracy that we're looking for when we're going into doing our full BIM design model. So this is where we start to bring in some of the laser technologies that you've seen throughout the conference. The nice thing with this laser technology nowadays is that it's really advanced, and we get accurate geo-referenced laser scans with true RGB color. Now this provides us the opportunity to really identify the individual pieces and parts within the structure so that we can properly model it as an existing condition. So now we've got this point cloud data. We can bring it into our BIM design software, and this is where we can really start designing the existing conditions of the facility. So as you can see here, we've got individual pieces and parts, walls, slabs, windows, piping systems. All this has a unique identifier so that we can track it throughout the design process. The other nice thing is this is where we start to bring in the information to the project. This is where we can assign concrete properties, we can assign analytical information to the concrete, to the columns, to the different components. And we also have the capabilities with the point cloud data that we brought in to automatically scan that point cloud data for piping systems. So that really speeds up the process in creating the existing model. Now that we have this existing model, what we're able to do is we're able to combine that with Rael's SiteSnap technology to have a true existing condition. This is where we can start doing our optioneering. So with this layout, we can bring in new structures, we can modify the existing structures, we can really give our clients a good idea of what we're going to do with this project. Now, if we want to go a little bit further, a step further, we want to get into the inner workings of the structures. Well, now we can move a little bit farther and bring in virtual reality. We've seen a little bit of this earlier in the presentation, or in the day, but here is where we can do the full immersion within the model itself. So in this model, we're able to walk through the structure with the other design engineers. We can check for clash detections with each system. We can check to make sure that the piping's not running through my column. We can run the cable trays. We can make sure that the design function as necessary. We can do hazard assessments, and we can even bring in operators and the owners into the design to have them look through the design of the facility to make sure that it's meeting their needs. Once we have the complete 100% design model, now we can do our last minute checks. We can check for clashes between the other disciplines like we previously did, but really verify that the model is complete. We can also get a better cost estimate because now we know every piece and part of the structure that we're building. It really helps us moving forward and giving the owner some confidence on what we're providing them. Part of the design process is that we do have to submit construction documents to the state. That's 2D drawings. Nothing fancy about that, but the nice thing that we're able to do is now we're able to bring in a little augmented reality to the picture. So you have some technical people, some non-technical people. The nice thing with this is that the technical people can look at augmented reality view of the structure by using QR codes that can be placed on the drawings. The non-technical people can look at the 2D drawing just as they typically would. So it's a nice balance of the technologies that is still very relevant for us. Now the other nice thing too is with this 100% design model, we can combine it with the SiteSnap technology that Rael has developed earlier. We can take this to the community. So now they can see what it actually looks like in the real world. So nobody likes an eyesore in their backyard. Everybody's concerned with that. So this really gives the community a nice, comfortability level on what they're getting. So usually this is where the model dies, just like our video dies. But what we really want to do is we want to keep this model alive. We want to take it into the construction industry. So what we can do with this is we bring the model into the hands of the contractor. Here's where they can, let's see if it works. No, okay, forget that one. Here's where they can go into 4D, 5D production. So with this, they're able to take each part, each element that we've already designed, and they're able to assign it to a specific time scale. So with that, they're able to track the progress of the construction. They can also look at the cost value of each individual element within that cycle. So it just gives them a great way to track the progress of the project. The other nice feature is that because you can do design of each element and when it's going to be constructed, you can also bring in other trades into the equation. You can schedule them so that they're not overlapping, and it just makes a very efficient construction process. So one other portion that we like to do within the construction area is we'll take automated documentation of the process. So at the end of the project, if there's punch list items or things that need to be finished up, that is all controlled electronically, and it smooths the process quite a bit. Now that we have the full construction model, we try and engage the contractor to make sure that that model is kept up to date as much as possible, or we ask them, the design engineer, to keep that project up as well. And the reason for that is that when we roll into O&M, or when the project is complete, we can provide that model to the owner. Now, the nice thing with this is that you can see here on the left is the actual built facility. The one on the right is the digital representation of that facility. And so with augmented reality, now we're able to give the owner the ability to look at any piece and part of their facility with the associated data. So the nice thing is we can have hyperlinked cut sheets with that. We can have operation and maintenance data. Anything you want to know about that equipment is there for their use. So now that we've gone through the complete design cycle, we start the process over again. So the more iterations that we go through this, the better we get and the more efficient that we become.
Okay, and we had a nice little video here of the Panama Canal that we wanted to show, but really basically what we're trying to do is with MWH's vision, we deal with water and wet infrastructure. And we're trying to take that knowledge with this, with what the people and the engineers that were within our company and their vision, and we're combining it with all these technologies to build a better world. Thank you.